Alright, everybody in their places. You guys ready on that?
Ready on that.
Ready in the blender?
Ready in the blender.
Tenfold. Go ahead and swap me the ass.
Let's get it fram. Hotel wake up call got me getting up.
Today we're going to go over the quadrature output module and the new firmware available in 3.2 that actually functions this. Now, just because you don't have the latest firmware doesn't mean you can't use this. It just you will not be able to use this to the full functionality. So here's the new quadrature output module. It's got a switch on the back. There's 3 different settings for voltage levels. Connector of this, of course, is going to hook into the FracSim meter on the right-hand connector, and on the front of the quadrature output module we got another switch. This is to reverse directions. 2 LEDs that indicate the status of the digital outputs, and then these, of course, would be one of the signals, the other signal, and then the black would be ground. So I'm just going to go ahead and set this up here. And of course, what we're going to be using today is FracSim, the module itself, and I have a little Redline Cub 5 that has a quadrature type input set up on it. Plug this in here. Put some power onto this. Ground. Flip this around so you can see the LEDs a bit better. Hook up the 2 outputs. So from the FracSim, if you go to simulation mode, and then you're going to go to quadrature, which is 7, so shift F7. Now, when it's first powering up, you'll see those lights flickered a bit. That is normal. So basically, if you were trying to use the totalizer function, you would power everything up, and then plug everything in, or reset the totalizer and then start using this functionality. So basically, there's 2 methods for running this. Now, the first method would be basically you set a number of counts you want it to pulse and the speed you want it to pulse at. And by default, it comes up with 500 pulses at 20 Hertz. And in the center, it says enter to run. So if I hit enter, it's going to run for 500 pulses at 20 Hertz. And you see up here in the display, changed from the 500 to running, and it still displays the speed at which it's going at. You can see the LEDs flashing here and the totalizer incrementing. And when it reaches 500, it should stop. And it did. So what I'm going to do now is I'm just going to reverse directions. I'm not going to change anything here, I'm just going to hit enter. So it shows it's going to do 500, enter to run, 20 Hertz. And now it's going to count back down because we hit that reverse switch. Now this would be particularly handy if the encoder system, measuring system, was working, but you were not sure if it was working accurately. Then what you could do is put in a large number of pulses, like 1,000 Hertz, 5,000 Hertz. And maybe you were worried that you're overspeeding it. You could put in a really high frequency like 5,000 Hertz and just see if you're actually overspeeding the counter system. And to demonstrate that, I would go if I wanted to increase the hertz, I could just go over here, press F4 for adjust, and I'm going to put in something really fast, 5,000 hertz. So 5,000 hertz for 500. Let's see what it does now. Well, it looks like we didn't overspeed it. It should come up pretty quick there. Let's go the opposite direction. Yeah. Let's try it for a longer number of pulses. So I'm going to go into adjust the counts over here, which is F9. So Shift F9. I'm going to put it up to 5,000 pulses. So I'm going to press enter. So it counted right up to 5,000, no problem there. Now if you wanted to test something continuously, if you were just troubleshooting and you wanted to find where the issue was, the number of pulses might become a pain if you keep having to restart it. So if you look here, it says number 8 is off on. So what you can actually do is just go Shift F8 and the screen changes to on. You don't see that enter or run anymore, and basically the output is continuously on at whatever hertz you set. So you can see the counter is just going nuts here because we're at 5,000 hertz. We'd slow it down to say 20 hertz. You'll see it slowly incrementing there. And same thing, you can always just forward or backwards, switch it back and forth. This module here is powered by the 24 volts out of the FracSim meter. So basically just the one cable you got to hook up. It's pretty straightforward. Now if you don't have the new firmware, you can still use the encoder output module. I'm going to show you how to do that. Basically we're going to exit out. So from the main menu you're going to go F1 simulate, and then just go to the regular frequency simulate mode. And then from here there's a couple things you got to make sure. You got to make sure your output is set to 24 volts. You can see right now the counter's not working, the lights are jammed on. So once we're at 24 volts, basically it's just going to simulate that frequency. Now the way this thing works, it actually takes the frequency and it divides whatever is going out to it by 4 for this output. So 200 hertz would actually be an output of 50 hertz. So if you wanted 1,000 hertz, you'd have to put this at 4,000 hertz. So 4,000, and now we'd actually be doing 1,000 hertz. There would be no totalizer functionality, but you'd still be able to test encoders and make sure they're going backwards and forwards correctly. One more thing I might recommend, if you were going to be doing a lot of simulating on a certain type of encoder, what I would actually do is round up an old broken encoder, take the connector off, and solder a couple wires onto the back of it, so you could go directly from this connector to a couple banana jacks like this, and that way interfacing in the field or in the shop, wherever, you can just quickly plug in your couple leads and screw this or whatever type connector end you have directly into your into the unit to make the whole system a lot more efficient. And that way all your connections are good and solid. You're not dealing with trying to ram in incorrect pins into a connector, especially if you're trying to use the totalizer mode, because if you have just a millisecond of a bad connection, you're going to end up totaling or falsely totaling an incorrect value.